morning children, welcome to the online class. Children, in our previous class we have discussed only some part of boiling concept, but here in this class we continue that concept and we put an end to it. Okay children, we are discussing how bubbles formed in the water. How bubbles are formed in the water. So this is a glass tumbler I am taking. You can assume as vessel also, no problem. And this is all water children. When you are providing supply, when you provide any heat children, or you supply any heat to this tumbler, you know in the water there is a water molecule. There is a water molecule children. That is nothing but H2O. This is a water molecule, and this H2O is a combination of some atoms. Means suppose this is a O central atom, two H atoms are combined children. H O. Understand? These three atoms form as one molecule, that is H2O. Like the number of H2O molecules are present in the water, and along with that molecules, I said that gases are also dissolved or presented in the water children. So while you are heating, while you supply any heat energy, whatever the gas particles are present in the water, they start rise in the form of bubbles children. At the bottom of the tumbler or at the walls of the vessel, they start to rise like this. But they need some temperature and some pressure. After getting some temperature and pressure, they rise up to the surface of the water children. But before only, water contains molecules, no children. All these molecules started moving in random direction. By the concept of evaporation, you learned that all the water molecules present in the water, they start moving in random directions with different speeds children. While during their motion, they may come closer to each other and they collide with each other, they lose their energies. This lost energy is given to the other molecules. The concept is evaporation. Here too, in the water, the molecules also gains that heat energy and they converted into the vapor. Okay children, you take a little water in a vessel and you start heating. Within a minute, it all rises into the form of vapors. You will see the vapors coming from it. These vapors are nothing but water molecules changed from the phase of liquid to gaseous children. So whatever the water molecules that turn into the vapors, that will be come and situated or being present in this bubble children. Means right now this bubble is filled with the vapors. Okay, this bubble is filled with vapors. Vapor is nothing but the water molecule. Understand? The water in the gaseous form is called vapor. So all the bubbles in the water are being filled with the vapors. If you start supplying heat continuously at certain temperature and certain pressure, all the bubbles gets their energy and they rises straightly to the upward children, and they come to the surface of the water and they start bubbling and will come to the surface of the water, and there they disperse the vapor which is present in the bubble into the air children. They burst, they come up and they burst, and all the vapors are being released into the air children. So then when this process is continuously happens, all the amount of or the level of water decreases children, because you are providing supply of heat continuously. But children, one more thing you should learn, that the boiling point of water is 100. Okay, children, this all bubbling concept happens at 100 degrees Celsius only. I said a certain temperature at a certain pressure. I said no, that is nothing but 100 degrees Celsius temperature is a certain temperature, and 1 atomic pressure, children. I write in short form ATMP, nothing but atmospheric pressure. At 1 atmospheric pressure and at 100 degrees Celsius, the whole concept of bubbling arises, children. Understand? The bubbles will arise and they release vapors into the air. Understand? So this is the concept of bubbles arising in the water, children. So in the concept of evaporation, we see that at any temperature, for children, at any temperature, the evaporation may happen or takes place. But in this boiling concept, it takes place only at 100 degrees Celsius only. All the bubbling will happen at 100 degrees Celsius only, not in 20 or 40 or 60 or 70, 80, nothing, children. Only at 100. Even after 100 degrees Celsius, if it attains, it never takes any heat energy, children. At that 100 degrees Celsius, it never take any heat energy, even if you provide a lot of heat energy also. It never takes because it attained. Understand, children? So next is latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. What is this, children? Children, latent heat of vaporization is nothing but the amount of heat energy, required to raise the 1 gram of water to change from the phase of liquid to gaseous is called latent heat of vaporization. Okay, children, I am taking a vessel. Again, I am taking a glass tumbler, and in this glass tumbler there is a 1 gram of water. Only just 1 gram of water. 1 gram of water. You can write gram, or you can also write 1 ml of water. Okay, children. Okay. So 1 ml of water is present in the tumbler, glass tumbler. So to convert this 1 ml of water into gaseous phase, definitely we need a heat energy, children. So how much heat energy is required to convert this 1 gram of water into from liquid phase to gaseous phase is called latent heat of vaporization. So latent heat of vaporization is denoted by the letter L, children, and the formula for it is Q by M. What is Q, children? Q is nothing but heat energy. Heat energy is represented by the letter Q, children. And what is M? Mass. Okay, children. If you want the latent heat of vaporization value for this water, you need some amount of heat energy for some amount of mass, children. Understand? So this is some amount of mass of water present in the tumbler. For this water, definitely you need some amount of heat energy to convert from liquid phase to gaseous phase. Understand, children? That is latent heat of vaporization. And you should also know the units of latent heat of vaporization. So there are CGS unit and SI units. CGS unit, it is a measurement, children. C means centimeter, G means grams, S means second, and SI means, you know that, international standards. So CGS unit of latent heat of vaporization is calories per gram, children. Calories per gram. What is the calories or grams? I am not able to understand. So children, latent heat of vaporization is measured in CGS and SI units. If suppose if you go to market, you want to take rice. You will ask to the shopkeeper 1 kg. Kg is nothing but what? A unit. You are going to uh, dairy, milk dairy. There you are asking 1 liter of milk sugar. This liter is a unit. Okay, unit nothing but to measure. Okay, liter is used to measure liquids. Kg is nothing but kilograms is used to measure the masses, any masses. If you consider my body, I will be right now as 60 to 70 kgs. My whole body is the weight of my body is like a 62 in between 60 to 70. We assume like that. So my body is also measured in a unit called kgs, kilograms. If you want to go distance, if you want to go from Vijayawada to Visakhapatnam, you know that the unit used for it kilometers, km. Okay, to have a cloth to use as a uniform or as a dress, definitely the cloth is measured in meters. So all lengths are measured in meters and kilometers and centimeters like this. All masses are measured in grams, kilograms, pounds. Time is always measured in seconds. No? So CGS unit is one kind of unit and SI unit is one kind of measurement unit used to measure the latent heat of vaporization. So CGS, we have said calories per gram. Na? So children, listen carefully. This calories is used to measure heat energy. Suppose you supply 20 calories of heat energy. For grams is always measured for mass. Okay, children. Here mass. So 1 gram. 20 by 1. 20. So the latent heat of vaporization is 20. Understand, children? Next, SI unit, International Standard, children. That is nothing but joule. Joule per kg. This is higher unit when compared to the CGS. So heat is measured in calories as well as joules. Work. If you done any kind of work, that is also measured in joules, children. Okay, heat, work, power, all these power is nothing but power is measured in watts. Okay, so work and heat are measured, energy also measured in calories and joules. And coming to the mass is always measured in grams and kilograms. Understand, children? So this is a higher unit. SI unit is higher unit when compared to the CGS unit. Understand? We can use both units to measure. Understand, children? So you might have understand the whole concept, children. Boiling is nothing but the phase of change from liquid to gaseous, children. And this boiling takes place only at a constant temperature, that is 100 degrees Celsius. Up to 100 degrees Celsius, the water temperature rises 20 to 30, 30 to 40, like that, continues up to 100. After attaining the 100 degrees Celsius, even though you supply a large amount of heat also, it never perceives, children, because it attained, that is a final point of the water. Okay, 100 degrees Celsius only, it converts the water, means liquid phase to gaseous phase, and all the bubbles will arise only in the constant temperature. Okay, children, we'll discuss next concept, melting and freezing, in the next classes. Thank you.